Catcher in the Code takes its name basically after Catcher in the Rye fantasy, which is a fantasy of a young man from the novel of the same name, Catcher in the Rye. And the young man's name is Holden Caulfield. And there's a field of rye and children playing in that field and running around, enjoying their time. And in the end of the field of rye, there is a cliff. And the catcher's role is to catch these children before they fell off the cliff. And it's kind of metaphor. I see it as a metaphor for catcher saving children from losing their innocence, from growing up. And it kind of makes me thinking, and it's every kind of fantasy story, it makes you think in a weird way. Like, it does not go straight. You kind of try thinking around and seeing all the connotations. And I'm like, I think we're that kind of catchers with the code. We don't let the code grow up. We don't let the code reach its maturity. And we kind of focus on getting things done on the algorithms, on the code, on the mechanics. We don't focus on the code as the means of communication, on the models, on the language. And so this presentation is going to be mostly about the need of communicating through the code, of actually telling the stories with the code, the stories, what happens, how the business model, how the business works, treating code as a means of communication, of telling a story. The important thing is, how do you learn to tell a story? And I have my own experience with learning to tell a story. When I first started my university, we were learning C language. And the way you learned C language was like learning for loops and if statements and all the algorithms and basically sculpting a statue. It was like writing one line of code. It doesn't work. Writing another line of code, changing it like 10 times, and trying your code to make things happen, to actually do what the requirements want you to do. It was an awful process. I didn't care about method naming. I didn't care about variable naming. I just wanted to pass. So it was basically like treating my keyboard as a chisel and making this sculpture and trying to get this done. It was good times. But then I learned that you can actually tell a story, that there are different ways of making your code actually say something, speak something. There is object-oriented programming, there is functional programming, there is TDD. There are all these kind of ways to help you to make your model look better, to make your code look better, to make your code actually structurized, able to be comprehended by other person. Because when you're in the university, you often don't think, you don't care that there's going to be another person. It's just 1 week, pass an exercise, you're done. And what I noticed is that these different paradigms, they have their own way. And they have their own practices, their own principles, and they're often in conflict. Like dynamic domain model. Dynamic domain model is an anti-pattern in object-oriented programming. But when you're writing functional programming, it's actually the way to go. So then you think, oh God, so what is the right way? And after some time, I think I actually started to discovering it. The right way is to tell a story. And different languages, different paradigms, they have just a different way of telling a story. And so when you think about coupling, SRP, solid, all this stuff, it's all about telling the story the way you should in a particular technology, in a particular language. Because the essence of good tell about a code is simple. The code is about two things. You either use it or you change it. And you might think, yeah, I read it. Yeah, you read it because you want to use it or change it. So if you want to tell a good tale, a good story with your code, you need to focus on two things, on use and change. I remember the first time I saw object-oriented programming, I started learning object-oriented programming, there were these things, access modifiers, and these things, access modifiers, they were weird things, because I was like, okay, so we have this private, you have this public, you have this protected, I can write it, I can delete it, I don't need it. Why do you need it? I mean, I can change it every time I want. And then you start working in a real project, the project that does not end in 1 week or 1 month. And you're like, oh, so that's what these guys are for. And these guys are for communicating with other fellow programmers, with your future self, because your future self needs that. And so the access modifiers are actually ways of shaping the story. You say, okay, these little things, they're going to be private. They're not going to talk to other objects. And these things are going to be public. What does it mean? They can actually get tied down to other parts of the system. That's how it's going to grow. Because project is ultimately a journey. Project does not last for 1 week, does not last for 1 month. Well, sometimes it does, but rarely so. It lasts for a few months, a few years, 10 years, 15 years. So a project is a journey. You need a map, you need a diary, you need a logbook, you need all this stuff, and your code is all of it. And you need to treat your code as such. So it needs to make sense. It needs to be a map. It needs to, you need to be able to actually conceptualize what is happening in your project by looking at a high-level overview of your projects. Your objects need to be named well. They need to tell a story. They need to be well connected. So when you look at them, it actually is a map. I have that project, that module, who is kind of a diary in a way. And it showed the story of being changed by too many people. And you could see that. You could see that because when you saw that project, it was really good. But at some places, in some areas, it was like, why would somebody do that? Why is it that here and that here? It's kind of inconsistent. And then if you started digging into it, you learned by speaking to other people that this project started by being maintained, created by one person, and then people started jumping in and changing stuff and making a story a mess because there was a consistent story. And people started telling their own tales, their own digressions. And a lot of projects are like adventure games, like Monkey Island. You probably remember that, the Monkey Island adventure game. So every adventure game is basically like that. You have like your inventory and your items and the world around, and you're like trying everything on everything else. Like in my project, right? I was like, okay, let's try making something. My favorite example in that game is like when you have to undo a screw and use monkey to do that. because monkey is a monkey wrench. Monkey wrench in Polish is klucz francuski. And so you're like, yeah, that makes a lot of sense if you're on crack. And you gotta remember, that when you make that story, when you create these names, when you invent these names, you need to change them eventually, because we, as humans, we like naming our things, and we stick to it. There's that first possession heuristic, and you can observe that in children. If you have a Jane, Mark, and Stanley, and you put a doll, and Jane starts playing with that doll, then Jane is an owner of this doll. She owns it. It's hers. Because she was the first to start playing with it. We cannot fall victims. We cannot fall victims to it. If things change, if we get better at our models, at our language, if we know our model better, our business better, we need to change the way things are named in our code. Because naming is important. Miss Lara Badeński from, I believe, either MIT or Stanford University, she made that nice research. And so they invented that city of Addison, and city of Addison had a problem with crime. And they presented that problem of crime, they framed it in two ways. Either as a virus or as the beast. And for half of the people, they presented it as a virus, and for another half of the people, they presented it as a beast. And people came up with a completely different way of solving the problem. On one hand, if you were presented with a problem of crime as a virus, you thought, we need a systemic solution. We need to make social reforms. And on the other hand, if you had a problem of crime as the beast, you thought, that's the beast. We need to forcible solutions. We need to increase the number of police. We need to tighten the law. And you can see how easily framing the same problem, showing the same problem as two different things, calling it by a different name, is basically making people think differently about it. Think about your systems, about your user services, about your Fuber classes. And so bridges need to be bridges, and gangways need to be gangways. If you call something what is a bridge, if you call it a gangway, and the gangway in Polish, I hope, is kładka. If you call it a bridge, you're basically telling a different story. You're telling it's temporary. You're telling it's something that's gonna change. So you're basically making people think differently about this concept. I have an example from one of our projects. We had that visitor class. It was a visitor inheritance hierarchy. It was a cool thing. It was a design pattern. And the problem was that it was not a visitor. I was like, it's a visitor. It has a single the interface has a single method which does not take any arguments. Yeah, that makes sense. It was a comment. I learned that like 5 hours later. And again, word meanings, they are changing. So you gotta face that. If you progress with your project, you learn. When you progress with the project, you learn. And when you learn, different things start being different things. It's kind of like a third-class movie, you know? Like a third-class movie when you have that good character in the beginning, and in the end, it's a bad character, right? It's like they become a bad character. And you have these things in your projects. And coupling, cohesion, all these concepts. It's not like somebody came up with it in the middle of the night like, woo, I wanna invent coupling. These are not magic things that somebody pulled out of the hat. They make a lot of sense. If you have hop coupling, if you have cohesion, all these things, they are basically because you think certain way. It's all about the brain. You need to make your software the way that makes it easy for your brain to get it. One of the best examples, mountain pattern. I learned it from Uncle Bob Martin. Uncle Bob Martin, he basically presents you with the best pattern in the world to tackle legacy code. Like when you have a method which takes 10,000 lines of code. What do? You rotate you print it out. You don't need to print it out, but you can rotate your code. You have a mountain. You have a map. So if you scroll, you basically look at the number of and the indentation, and you know where you are. Awesome, right? But this is actually an example on how to deal with a certain problem with legacy code. You have a pattern that is supported by your brain. Isn't that awesome? Our brains, they like order. We like things that can be treated as patterns. We like consistent packaging. We like packaging at all. I mean, if you have a list of classes in just one package, that's probably not the best way to deal with that. You can probably do something about it. And then having a consistent packaging is really a savior for our brain. Things like fluent interfaces. They are predictable. You use them similar way. They help you. You always know what to type, at least in Java or other static languages. But this is the way to help your brain tackle the problem. And again, consistent and well-named classes, methods, objects, every structure, basically. And design patterns. You like it, you don't like it. Either way, sometimes they're useful. They are imposing certain amount of order. And order is something that your brain likes. The way to speak to your brain is also by having simple things. Simple and complex things are things that introduce certain amount of risk as hard, complex. I know it's maybe controversial, but reflection in Ruby and Java. Reflection in Ruby is really simple. So you use it. And it's really easy to have like a terrible mess. Because it's easy to do it. So you do it. That's how we roll. People are humans. That's how we roll. And there's basically a fundamental attribution error that people have. People assume certain things by their characteristics, by their nature. If you see things that are simple, we assume that it's not going to be a lot of risk involved in actually using them. But there is. Counterexample, simple. In Java, reading files, oh my God. It's like Every time I have to do it, I need to open like Google and Google for that thing. It's like, why would you do that? In Ruby, that's cool. That's simple. There's not a lot of risk involved. So let's make it simple. Simple things should be simple, and things that are risky should be complex. Pun intended. There's no picture. We should see other objects. So sometimes your design is like very, very decoupled. Nowadays, people have like, I don't know, like some kind of tendency to decoupling everything. I mean, I don't know. But it's like, I tell you one thing, low coupling. If you tell me low coupling is good, I tell you bullshit. It's low coupling, high cohesion. It needs to be together. You cannot do low coupling. You cannot have separate modules scattered around and then assemble them in a random, more or less random way. Because then, your design is basically like that. These classes are like, we should see other objects, you know, I need more space. And then your design becomes like a mess, a terrible mess, things scattered around. Nothing makes sense, basically. You don't know what goes with what. It does not tell a story. And your design needs to tell a story. It cannot be uber abstract concept. Yeah, bullet code. How many of you seen it, right? Basically code that seen places, been places. So a lot of code is like that. You basically, your code communicates and it's like, I don't like you. And you're like in that movie, you know, Abra los ojos, open your eyes. And you're like, code is like, open your eyes. And you're like, I don't want that. A lot of code, unfortunately, is like that. It's bullet code. It's code that, my story, when I was a bully, in the old days, you know. I'm no longer one, I hope. I learned the generics. I was abstract. I was so abstract. We basically had a system that overnight, instead of selling one type of things, say cat food, we could start selling boats because I had shopping item, I had shopping cart, product item, product, a lot of this stuff, you know. So abstract. I was so proud. I was so proud. It was like the art, the living art. Generics, oh man, they did not fit in a line. You know, right? And that's cool, right? Abstract. Overnight, different system. No, it's not. Because it does not tell a story. And the problem with abstract concepts is that they are abstract. So you need to maintain that. If you have an abstract interface, it needs to support all the current requirements and all the future requirements by methods, generalizing all the concepts. So in the end, you end up with methods like describe something. It's not the way to go. You need to tell a story. Another project, a story of another bullet project, we shall code in Java. And if you impose on your programmers, like overnight or almost overnight, they should switch from one programming language to a different programming language. They're going to tell a story. Oh, yeah, they will. It's going to be a different story that you probably wanted, but they will. And in that project, probably the best example was the best abstract interface I saw in my life. We had communication within the system, and we had a single method, an interface with a single method that took a map and returned a map. Woo! That's the way. Right? No, it's not. Again, your code needs to tell a story. I mean, bullet code tells a lot of stories, but you need to be patient with bullet code. Bullet code has its serious traumas. It needs to recover slowly. You cannot just get bullet code and like take it and say, now we need to get a grip. Nah. You get a bubble tower effect. Bubble tower effect is basically like people come to the project and they're like, oh, bullet code, I need to fix it. Yeah. And people end up fixing it many times. Everybody tries to tell a different story. Everybody tries to fix it their way. Eventually, because everybody is like so eager to save it, eventually you end up with a bubble tower. And you end up with a code that basically is more a mess than it was before. You need to be patient. So basically, a rule to that, to solving the problem with bullet code, the code that does not tell a story, is stop being smartass. If you have a code that has anemic domain model, leave it as such. It's better to have anemic domain model and maintain consistency than to start fixing it and leave 1/10 of a code base fixed and 9/10 of the code with anemic domain model, because another person is going to come to this project. And she's gonna, or he's gonna try to tell her his story. And they'll introduce functional programming. And then you have 1/10 of object-oriented, 1/10 of functional, 1/10 of, I don't know, Prolog, 1/10 of who knows. Imagination is the limit, right? So you need to tackle it patiently. So in the end, there are 4 simple rules to remember. There's 4 simple rules that I want you to remember. You probably know that. Always code as if the person who will maintain your code is a maniac, serial killer that knows where you live. Name your methods well. Don't leave a mess. Every step, think. On every step, think. Because you're telling a story. You're communicating. You're communicating with your future self. You're communicating with the maniac serial killer. And you want to send him the right message, trust me. You're basically, every time you change your code, you're changing the story of the code. You're changing what this code tells you. Name your methods as you would your firstborn baby. And it is not only methods, it is methods, classes, objects, variables, everything. Because names have a meaning. Names are important. We communicate with each other by using words. We communicate with each other by all these different words that have all these different connotations and denotations. They mean different things. You want a bridge to be a bridge. You want a gangway to be a gangway. And if your names are not right, you're going to end up with like a virus versus beast problem. People are going to assume different things. And they're going to grow on top of that. They're going to build on top of that. You want your story consistent. You want to communicate well. And write the code with your brain in mind. Things like coupling, cohesion, single responsibility principle, dependency inversion principle. All of these things, all solid principles, they're not pulled out of the hat. It's not like somebody just came up with it overnight. These are the things that are based on the way your brain works. People like when things that change together stay together. People like it, because if I want to change something, I want it to be close, not like in the other part of the system. It's almost like, giving a real-life example, it's like your guest comes to your house, and he goes to the toilet and wants to flush the toilet, and he's like, where's that thing that you flush it with? And he asks you about it, and you're like, yeah, that's very simple. You just need to go downstairs, open the oven, set it to 200 Celsius degrees, and wait for 5 seconds, and the toilet is going to flush. That's how our system works. Yeah, like that. You do this, and this thing happens. Okay, fair enough. Write the code with your brain in mind. You write the code for humans. My last, fourth, and the most important message is stop coding and start telling the stories. When I look at my code, I want to see classes and that speak to each other, that are connected in a way that makes sense, that I can have a high-level overview of my classes and see what happens. I want to be able to imagine the business model. I want to be able to imagine how the business works. I want things to be cohesive. I want a single class to do a single thing because it's easier for me to think this way, because it's telling the story. And people like stories. Stories are simple. Stories are the right way to communicate. And your code is about communication. That's all, folks. Thank you. Any questions? Comments?
Are there any questions? I guess there's no questions. Thank you very much for the presentation.
Thank you.